So welcome everyone. So I'm Yann Franc for those online. I guess the others in the room already know me through dinners and discussions. As Julien mentioned this morning, today is going to be heavily technical, right? So we're going to talk about things we are implementing in LUMIS. So what we try to do for this session is to be technical in a way, but also give you, let's say, the basic information for you to understand some key concepts like ontologies, right? Because we are going to talk about this. This morning, we had a very interesting presentation from Julien about interoperability. Interoperability is a multi-layer thing. And one of the top layers, the most important one and the most complex one to address, is human interoperability and not technical interoperability. Because if it all relies on techniques, we can easily develop services and connections and so on. We can agree on standards that easy. Now, one of the main issues is to get people to agree on naming things the same way. And make sure that when you start putting and inputting data, when you talk about a cat, everybody names it cat and not meow or kitty kitten or whatever, because that's the issue. If you ask a computer to actually look for that data, it will not understand on its own, even AI, and sometimes may have problems to actually understand that kitty kitten is the same thing as cat, right? And so when you're searching things or looking for data sets, if you have this semantic ambiguity or diversity, it makes things very complicated for computer systems to actually give you the right answers or the complete answers to your questions. And that's a little bit the idea of LUMIS, which is the Lumen, the Lumen semantic platform, because in order to help organizing data and add to the data semantics, which means the meaning we provide to the data, you need to build what we call ontologies or taxonomies, which will allow you to actually all agree on a set of concepts that when you start annotating and describing your data, you're going to use the same concepts in the domain, right? Or similar concepts. Sometimes you disagree. That's the point of science. We do not all agree on the same theories. We don't see the things the same way. So that's a challenge. In order to resolve or address this challenge, you need to build these ontologies or taxonomies to align things. And then we'll see later on that you can also connect them. So in a sense, this is a small introductory session today, this morning, about another session we'll have later on in the afternoon on Graphia, where we need to build an ontology for Graphia, right? And LUMIS is basically a platform that helps the people that build these ontologies to actually have a workspace where they can follow up the progress of the development of the ontology like you would do for software, right? And to follow a process so that these ontologies are fair by design, okay? So the goal of today is to actually present the platform to Lumen and Graphia partners, to dive into the world of semantic artifact creation for 2 hours, which might be tricky for some of us, I know that, and that's the difficulty of organizing this workshop. It's like we do have colleagues that are technical, with whom we are going to have technical discussions. But there are also people that are not necessarily technical. And I'll show you, we have a group that will discuss the interactions with non-technical people or non-experts on ontology. And what we want to do is, we're still in the design phase of LUMIS. We started discussing implementation with Julien on the task 2.2. So we have already the plan and everything, but we still need to decide on what are the key functionalities we want to have in the first version of that platform. So basically define what we call a minimum viable product that we can deliver as a first version towards the community so they can test, benchmark, and then give us feedback so that we can improve. And over the time during the project, we'll add more features and more functionalities based on the needs from the community. And I have to say that I really enjoyed the co-creation discussions yesterday. So I was interested to hear about AI, actually a bit annoyed by hearing about AI and co-creation, because I'm annoyed with the use of AI. I'm a neuroscientist, so intelligence is part of the things we discuss. And I've been involved in AI as well. And for me, the systems we have are not nearly intelligent enough for these kind of interactions. And my preference goes to co-creation with humans because that enriches your perspective, because all of us have a different views of the world. And this also makes it very difficult when you want to build an ontology, because an ontology is a model of the world. So we all have different conceptualization of this world. And at some point, we need to sit around the table and agree all together on a common one or on links between our different views. So how are we planning to work together during these 2 hours? Maybe we can shorten it up so we can get a break and a breather, because it's pretty dense program, but still I would like to thank Michaela and Andrew for organizing this. It's really good, great. We get brain fried every evening, so it's great. So the idea would be to have 3 groups, right? 2 technical groups, one discussing things we already collected during the first part of the project, which is called user stories. So we worked with ontologists within Lumen and with other colleagues to actually identify what would be their needs, right? So, and we collected them as user story, and we have 87 user stories already. So part of the work would be to discuss and review these user stories. It's been reviewed already, but then start prioritizing them, linking them to functional needs so that we can start an implementation. So in a way, it would be starting defining the minimum viable product. The group 2 would be defining the first architecture diagram, because the main idea of LUMIS is we don't want to reinvent the wheel. There are already good tools that exist that are widely used. I was in OntoCommons with Michaela, and there was an analysis of the usage of tool in industry. Protégé, for instance, is the main ontology editor. I think it's 75 or 80% of ontologists or people working with knowledge modeling in industry using Protégé. So we don't want to break the flow of the experts. We want to reuse the tools and try to connect them, which is per se a technical challenge because they all have been developed in silos. They all have different levels of maturity. So this is why we need to start discussing how we connect them together, and we need to group them into a coherent workspace. And the third group is something that came up from discussions when we presented within Lumen from the communities. Because LUMIS is a bit peculiar. It's not directly linked to the scientific communities, right? This platform is aimed for the people who are going to build the ontologies for these communities. However, it is impossible for an ontologist to be the domain expert, so we will have to interact with the different experts in the communities to actually build these knowledge models. And so the idea of the third group for the non-technical people is to discuss how can we build this bridge between the communities, meaning the experts from the communities, so that the person in charge, that can be a domain expert. That's how I started, building an ontology in neuroscience. They just drop me there and say, you build an ontology. Great. But then you cannot do it on your own, so you'll have to interact a lot with your colleagues to actually further refine, identify the core concepts, the definitions, and so on. So the idea is we start with presentations, right? So that we are all on the same page. You all understand LUMIS. Actually, how many of you know what an ontology is, really? Not just heard about it, but know what it is? 1, 2, 3, or 4. That's not, yeah. So that's not many. So I would like to start giving an introduction and have a Q&A so I can answer your questions on LUMIS and ontologies and what we call semantic artifact, because even among the ontologists, there are different types of ontologies with different levels of formalism. That goes from just simple code lists to very complex formal ontologies. And so at some point when we discussed among experts, we had disagreements because people from taxonomy world thinks differently than people from formal ontology world. So we decided to coin the term semantic artifact, and I will give you the definition. So that resolved that conflict. And so that allows us to actually work together on the same thing. Then after this presentation, and it's not going to be slide to death, right? But at least it's the necessary information. Then we have working together, and there you need to do some exercise. We've been sitting the whole day. So we'll move tables so that we can actually organize the groups, and then work with the groups, and then we have 10 minutes wrap-up. All right? What do we want to get out of this workshop? Well, we want to define this minimum viable product as far as possible. Okay, that's going to be also ongoing discussions in the regular meetings we have in the task. For this, again, we prioritize the user stories, define the initial architecture, and we want to identify the needed features to enable collaboration between domain experts and ontologists, taxonomists, and the needed feature also for newcomers. Like you get someone from mathematics that needs to build an ontology for mathematics and doesn't know how to do it, wants to go to the platform, so how can we help him to actually build a proper ontology and giving the hints on how to use the tools and provide the workflow and sort of thinking about training these people to actually efficiently use our platform. So we'll start with an introduction to LUMIS, and this introduction starts with what's an ontology or semantic artifact, right? This is a conceptual model of the world which describes the context, the concepts, their relation necessary to describe data and its context, right? So you collect data, it's in a particular context, you need to also explain the different concepts that describe that context. So here I'm using a very nice ontology on beer. That's something that everybody loves, right? So everybody knows. That's been built by a colleague, Silvio, who's a part of the task. So basically what you see is that in an ontology, you start by saying that everything is a thing, right? It's indeterminate. And then each of the classes, like a brewery, the beer, an award, the ingredients, they are all things, right? But these are more refined concepts that you will need to use. And then you can start building relations between these concepts. So basically a beer has been awarded with an award. Yeah? It can be brewed by, okay, and so on and so forth. It has ingredients and so on. So this is a formal ontology. This is another approach. This is a taxonomy. It's a classification of beers, types of beers. So you'd have ales on the top, lagers on the bottom, and then all the others are connected, and then you see the different typology. So it's a hierarchical relation. So you can think about another taxonomy, which is the species taxonomy, for instance, right? And so in our view, these are different models, conceptual models of the world, with different purposes, with different levels of complexity, but they are, for us, the same thing. They are semantic artifacts that we need to use in an information system. The aim of this is not to model the world, right, which is the original purpose of an ontology, which comes from philosophy. It is to actually model the data you have in information system for a purpose. So that gives you a scope and avoid that you have endless philosophical discussions on what a beer is and what an ingredient is, because you can end up having discussions for years with people and never agree on a definition. So let's be pragmatic when we build ontologies or semantic artifacts. So these semantic artifacts have different levels of complexity. So here is a slide I borrowed from colleagues from the biomedical domains. You have what we call controlled vocabulary. So it's a list of terms defined by a community. It could be list of disease. It can be the list of types of beers or names of beers, whatever. It's defined. They have an identifier. It's all clustered, so it's nice. And you can use that for, let's say, inputting this into your metadata. So you have controlled values in your metadata. Another one is the taxonomy that I just showed you with the beer. It's a hierarchical relation between the different concepts of the controlled vocabulary. So it's slightly more complex, right? You start to organize the types and subtypes and so on. And then you can also add things like, is synonym of, right? Because we don't use the same names to talk about the same thing. So basically you can do and express explicitly this relation of synonyms, right? That also can be used for multilingual, right? You can also say that some of these concepts in English are similar to this concept in Croatia or French or whatever. There are thesauri, which are taxonomies with structure, specific relationship between terms. So these ones, for instance, here, you have the disease and the proteins. You can add the genes that can be classified with a convention and so on. And then you can also provide the additional names. So for instance, we call that alternative labels. So a thing is named with, let's say, a chemical product as a chemical identifier, but then it has another name in real life, so you can also add this information. And then finally, you go to the more complex view, which is the ontology, where basically you have taxonomies and all these different complexity, plus you add relations that links this concept together. Like we've seen, beer has ingredients, and ingredients are part of another taxonomy, which could be a food ontology or food taxonomy, for instance, and you would link these together into the ontology. And the ontology can be very simple, but the power of ontology is you can add on top of the relation logical or mathematical formula from logic, from descriptive logic, for instance, or first-order logic, which will allow you to constrain the way the relation works and to actually further classify all the products. And so there are examples of ontologies if you go on the web. One of the most famous examples to learn OWL and OWL-DL is the pizza ontology, right? That's an old one. And then basically you define all the things you need to know about pizza, and then you define types or instances of pizza. And then you ask the reasoner to use the logic to classify the pizza, for instance, as a meat pizza or a vegetarian pizza based on the ingredients. So there are already tons of conceptual models that exist. There are very generic one. DCAT is one, right? It's a standard used by the European Commission now for all the public data coming from government. It's also being pushed in the science for fair data. And you can profile it. You have another one, which is very interesting, is PROV, which is a W3 standard as well, which allow you to model the provenance chain of things, where it's very simple, 3 classes, few relations, and then you can build an infinite chain of provenance. There are other ones that you may know already, coming from humanities, Dublin Core, for everything that is published. And there is another one, which was one of the first, which is the friend of a friend, or FOF, that exists, because these technologies have been also developed for, let's say, social media, how people are connected to each other and so on. Which led to the creation of knowledge graphs that Julien is going to talk in the next session. So basically, all the things you will see today are connected. They all work together. What are semantic artifacts? So as I was mentioning, if you talk to someone that does taxonomy, they use a specific standard and a different way of doing modeling than someone from OWL. And then when you start discussing the commonalities, like how do I want to make this artifact fair, then you end up in endless discussions, but yes, no, it doesn't work for me and this and so. So we agreed that we should define, let's say, a top-level concept that's a semantic artifact. And the definition is very clear. A semantic artifact is defined as a machine actionable and readable formalization of a conceptualization. So the ontology can be just a simple paperboard drawing, but at some point you need to implement that for machines. So you need to formalize it or serialize it into a format that the machine can understand. PDF or drawings, they don't. So basically, you have to put it there. And the idea is that a semantic artifact is this kind of implementation. And basically, this formalization of a conceptualization enables sharing and reuse by humans, of course, but more importantly for machines, right? And they can have a broad range of formalization from a loose set of terms, taxonomies, thesauri, to higher order logics. Moreover, they are serialized with a variety of digital representation formats. And this is the definitions we had in the Ferris Fair project, which is now over 6 years ago, no, 3 years ago, I think. So because we were actually discussing how to make them fair. So what are the common representations? So there are different ways to actually build the data model, basically, to represent the categories and the links and so on. So you have RDF, XSD is one way. You can use UML, you can use OWL or SCOS or the Hobo Foundry. So these are the generic things. And then to build the data model for the ontology. And then you have the serialization format, which can be JSON-LD, JSON, XML, Turtle, RDF XML, and in OntoCommons, we had a lot of fun to discover that a lot of the ontologies are just PDFs. So basically, you can't use them in an information system. Here is just a few examples of practices in various communities. So in biodiversity, for instance, GBIF, right now their ontologies are in XML. If you go a little bit further, you have Altair, it's a SCOS vocabulary. You have the environment ontology, which is an OWL based on obofoundry principles. In marine agriculture, food, and biomedical science, you get a lot of SCOS vocabularies that are served by the NERC vocabulary server for marine. In AgroPortal, you get tons of ontologies with different formats. You get OBO, OWL, SCOS, UMLS, and many different other formats. But mostly it's OWL and SCOS. If you go to the obofoundry, this is mostly OWL with the OBO principles. BioPortal, which is a resource I used 15 years ago. Basically, it's still there, and it contains 1,000, now I think it's 1,200 ontologies on biomedical domain. Most of them are in OWL, and several of them are in SCOS. So SCOS is used for taxonomies. In humanities, well, in linguistics, you have Clarin that is providing a vocabulary for linguistics. In SCOS, you have CESDA as well in SCOS. You have another resource, Vocabs, that is also SCOS. So for instance, you can see that there are trends in communities. Some of the communities are going toward OWL and more formalized ontology, while in humanities, for instance, you will find a lot of SCOS, thesauri, or taxonomies with lesser logical constraints. We also worked in material science and industry and manufacturing in OntoCommons together with Michela. So we also did a report there where we do the landscape analysis. We identify, if I remember off the top of my head, there's 137 ontologies for material science and manufacturing. Half of them were PDFs, amazing. And the rest is distributed in serialization. Some of them are XML, OWL, RDF XML, OWL, Turtle. Most of them are OWL rather than SCOS. There was also a nice work that came out from OntoCommon, and basically the idea is that semantic artifacts should be part of the standardization landscape, right? If you go to ISO standards, many of them have metadata schema defined in there, but it's stored in the PDF. They are not in a machine actionable format, so you can't reuse them unless you have to buy the ISO and then implement it yourself, which is a huge waste of time. So you have a large diversity of semantic artifact representation. This is coupled with the difficulty to find them, right? So you do get some ontology repositories, like in biomedical, like AgroPortal, some of them for humanities, but it's not the general case. You have to go to GitHub, but then if you start searching on GitHub, good luck. So basically, the best way to know if an ontology exists in your domain is to go to a conference of your domain and find out the guy who's doing a poster on an ontology because nobody cares, right? And so this is really not convenient. And they are in different format, different structure, different levels of complexity. As I was saying, XML, RDF, Turtle, and so on. So that makes things difficult for interoperability and reuse. So basically, these contributes to impair semantic interoperability, which was one of the aspects of interoperability. So the question was, how can we resolve the situation? And the idea is to say, let's apply the FAIR principles to the ontologies. We do that for data, but ontology is a model. It's therefore data as well, right? It contains, as elements of the data sets, concepts with definitions and metadata, right? So if we want to actually, because the ontologies are actually one of the key elements to make your data fair, because if you look at the FAIR principles, the principle I2 say you need to have metadata and data aligned with existing vocabularies that are themselves fair, right? And so we had a conundrum, because to make your data fair, you need to use fair vocabularies, but we don't know how to make fair vocabularies, and we don't have them fair. So in the FAIR is Fair project, we started working with the communities to actually see how we can make recommendations and best practices to help them making their ontology or semantic artifact fair. We worked with them to actually align these recommendations with the RFC 2119 that says which ones are mandatory, which ones are recommended, and which ones are optional. We ended up with 9 mandatory recommendations, 7 recommended, and 1 that was optional, and 1 undetermined. And so basically, also one of the things we realized is that FAIR says you need to add metadata. I mean, I think it's the principle F2, I don't remember the number, it says provide rich metadata. And we're like, what does it mean, rich metadata? Basically, it goes from 1 metadata field to an infinity of metadata fields. So basically, there's no boundary that you can set to say my ontology is fair because you don't know how much metadata you provide, and it's subjective. So what we started to do is to work on what we call the minimum metadata profile for fair semantic artifacts, which is actually based on an ontology that describes ontologies. That's called MOD. And we integrated that with DCAT so that you can publish collections of semantic artifacts. So some of these recommendations were use a globally unique, persistent, unresolvable identifier. In many cases, that's not the case. It's not resolvable. So you get ontologies that have, ontologies are web-based entities. They come from semantic web. They have a URL, but then when you start pinging the URL, it doesn't give you anything. So basically, it's killing the purpose. We don't use the same way of minting these PIDs. In many cases, you will find the name of the concept in the URL, which is not necessarily a good practice, because if you end up having things like antonyms, well, you have twice the same identifier for 2 concepts that are different, so that doesn't work. So, and basically, they do need to resolve to their content, which means the concept, but also the definition associated with the concept. If I talk about a cat, but I don't say what I mean through the definition, you can't understand how to use it. So you need to enrich the description of the concept with definition, example of usage, who actually provided that definition. If it's coming from somewhere like a dictionary, put the resource so that we can go back to the definition and so on. And also, this concept evolve over time. Your ontology is not a static thing. So you have also to input versions, and it's often not the case. So you need minimum machine-readable metadata to describe this semantic artifact. You need to use repositories or catalogs to publish your ontologies. And so we now see a trend where we have a growing number of domain-specific services, registries, or repositories to publish ontologies. And some common examples are Bioportal, AgroPortal, Industry Portal that come out from OntoCommons. So these are places where you can actually drop your ontology, and then the system makes the content of the ontology available through an API, which means a machine can actually go to that resource and use the resource directly rather than going to a GitHub link, download the file, parse the file with all the problems that can come up with in order for you to use locally on your system an ontology. So that's why we push for this. And you need to have common APIs. I mean, if all these registries have different APIs, then it becomes a nightmare, because every time you want to connect to one specific repository, you need to build one specific script to get access to the same data, which makes it unsustainable if you start working with hundreds of them. And so we also need, and that's something that's follow-up from Fair is Fair Impact that just finished this year. We just had the review yesterday. Basically, the idea is that these models, they need to coexist. And that goes back to what I said before. An ontology is a conceptual model of the world. It turns out that if you think about it, you personally have your own ontology. We all see the world differently, right? So it is impossible to agree on one common worldwide ontology, because we all have different perspectives coming from culture, education, whatever. And so basically it's the same for ontologies. These ontologies represent these views, so they will have to coexist. And then you have to do the work of mapping, which is the work we do when we build other ontologies, which is sit around the table with 10 different persons with different views of the world, and then start having discussions on how what you think is this relates to my view of this, right? And then we do what we call these mappings. So you can start bridging these different models together and start building links between these things. But this is extremely costly. It takes a lot of time and a lot of effort to actually do this mapping properly. So these mappings need to be published as well, and they need to be fair as well, because they are part of the ontology, right? And you should be able to reuse them, right? So they need to be documented. You need to understand in which context they've been developed, and so on and so forth. So if you have questions, just interrupt me, because I can speak about this for, well, I've seen that with Andrew yesterday on the podcast for 45 minutes, and can do more if you want. But that leads to LUMIS. We have these recommendations. There are several. Yes, sorry. Whoop. Mike.
It was about the report, the Fair's Fair report, because it says a recommendation that says it's the third iteration.
Yeah.
Just like in your own summary words, what kind of changed, do you think, the most from, let's say, the second iteration to this third iteration?
So in the second, we added up the classification of mandatory, recommended, and optional. And we've been working iteratively with the communities to actually refine the description of the recommendation so that it's clear for everyone. So it's actually semantics evolution. There was no dramatic evolution from the first set of recommendations, just the way we formulate them and the way we explain them and so on. So basically that's... There
wasn't any, like, let's say, one or two things that kind of, let's say, triggered updates and stuff. It was just feedback on wordsmithing.
Yeah, well, there were some updates, so we refined some of them. I cannot give you on top of my head which one changed.
No, it was just more just your general feeling of what you thought kind of changed between.
Well, we have been working intensively with the communities, organizing several workshops, collecting a lot of their feedback in different contexts. So in the context of the project, but also during RDA meetings, where we had the international community coming there. So we actually consolidated quite a lot in the first version. And then the second and third iterations were more like refining, reshaping, eventually looking at the correspondence with other recommendations that were actually provided at the time, so that we make sure that we align and you don't end up having 20 sets of recommendations for the same thing.
Do you think the number of recommendations reduced or remained about the same? They just kind of changed?
I think it remains about the same, yeah.
And things that are like mandatory versus optional? Kind of more or less.
That didn't change much.
Okay.
Yeah. That didn't change much.
Okay, perfect, thanks.
You're welcome. Any other question, comments? No, you're now all ontologists. So, you see, building an ontology is not easy. It requires tooling. It requires a lot of work, a lot of interactions with the communities, because you can't do this on your own. Otherwise, you would impose your own worldview, which is wrong for a domain. And even you have subgroups in domains that disagree on models, so you have to make that properly. And you need to make them fair by design. So if you look at the ontologies, the number of documented ontologies with proper metadata is very low, because you spend so much time building the ontology that you don't care to describe the ontology itself, who contributed, who's the main author, the version, the dates, and so on. You get a lot of these ontologies that are out there. Some of them are very nice, but they are not even maintained. They're not used. The same goes for the recommendation side. We don't even know right now how many of the recommendations we made on the FAIR semantic artifacts are actually implemented, right? And so we know that the current practice is not documenting your ontology, making it fair, right? It's just dump your ontology somewhere. It's already be a pain to build it, and I don't care for the others. I use it for my own purpose. I don't want to share, or I don't care to share. So the idea is to change that. So you can change that through education, or you can change that through integration within the tooling that exists and making the life of the people easier. Filling in metadata for a scientist, but for an ontologist the same, is just pain. Like, terrible pain. And if you do that after generating the data, it's even more painful. So the idea of LUMIS is to say, there are tons of tools that help you assess the quality of the ontology, check the fairness of the ontology, that actually helps you build the ontology, publish the ontology, document the ontology, but these tools are distributed. There are sometimes 3 or 4 different types of tools that does the same thing, sometimes slightly differently and so on. So the idea is that, well, instead of being an ontologist that needs to, okay, I build my things on Protégé, and then I go to that service to check if I didn't make some common mistakes in the design of my ontology. And then I go to another service to make sure that actually it's fair. And then I go to another service to publish it. And then I go to another service to document it, and so on and so forth. We wanted to aggregate everything and to follow a process and integrate with the tools the different recommendations on how to make them fair and automate things like, well, metadata capture, right? You shouldn't input who's the creator. The first guy who created the OWL file, he's the creator. And then the others that goes and collaborate to this construction of these ontologies would be automatically contributor. And this you can capture if the people log in into a common platform, because when they log in and contribute, then you can take their user ID information and it's automatically filled. The same goes for version control. Many of them do not use version control. So if you add and provide version control, then this is automatically done. The guys do not have to think about it. It generates all the metadata and the necessary links. It's good, so you just click and click and click, because that spares a lot of time. And the same goes if I go from creation and I would like to publish it into, I don't know, bioportal, agroportal, or anything. I should have a button that says publish. Then I arrive, then it asks me some information that are necessary for the publication, and whoop, it's automatically published, right? And so that the idea is to aggregate all these tools that already exist to make the life of the ontologist or taxonomist easier, and also control the quality of the semantic artifact themselves. And that comes back from a talk when I was starting in that field. We organized a workshop because we created the European Ontology Network. The idea was to get ontologists together to talk about best practices. And we organized a workshop, and we had a colleague from University of Manchester that gave a very inspiring talk about why don't we apply software development good practices to ontologies. They are not necessarily code per se, but these are part of information systems. Therefore, you should apply the same principles than when you develop software, right? Version controlled and automated tests and things like that, so that actually it makes things easier for the ontologist to guarantee the quality of the ontology. And that's the idea of LUMIS. So we want to integrate open source tools into a coherent workflow for ontology/taxonomy experts, unify this platform for creating, testing, publishing, maintaining, governing semantic artifacts, support the creation of new ontologies fair by design, but also support the reuse of these ontologies and the verification of existing ontologies. Right? There are some ontologies that are widely used, but they are not fair. So maybe you can contribute and update to upgrade a new version by adding the metadata that is missing or other things that are missing so that you make them fair. Provide standardized API to connect different other tools that will use these ontologies, like annotators, converters and enrichment tools for metadata and data and so on, so that basically that wealth of models can be directly used for the verification of data, right? Also, this is important. If you want to test the quality of an ontology, you need to see if it works. And it only works if you use and add data to it. If you don't, well, you cannot test your ontology. So basically, the idea is that the semantic artifact in the context of Lumen are treated as data product, like you would do with data sets, let's say satellite images, surveys, whatever. And they will be then integrated part of the Lumen data mesh. So we want to ensure also decoupling, alignment, and discovery, which is very important. When you start building an ontology on a domain, you arrive on Protégé or any other tool. You have no clue what are the other ontologies and what kind of concept they contain. So if you really want to make it and reuse, you have to go to the different sources, look at the ontology, analyze the ontology and say, they have the concept already defined, so I need to import that concept so I can reuse. The most common practice right now when you do imports in ontology is these are text files, right? They are literally text files. So the guys take one text file, copy and paste, put it in theirs. There's no provenance information. So if the ontology change later on, you have imported something that is not right anymore. You work with something that is completely different now, and you don't even know which version were used, and so on. So basically, you lose a lot of things, a lot of information. So we need to change that and help with imports. We need to make sure that these artifacts are published in thematic catalogs or generic catalogs. So that's why we are already collaborate with the people who developed the bioportal, agroportal. It's the same technology. It's called ontoportal. Julien presented the beginning of the week to the ontoportal alliance. So we want to directly connect with them so that basically people can streamline the publication of their ontologies or scarce vocabularies there. We want to aggregate concepts from this resource. So there is a technology we developed in the context of Fair is Fair, where basically the idea is that most of these repositories of ontologies or semantic artifacts, they have an API. They are all different. That's painful. So we have a system that allows you to document the API so that it automatically harvests the content. And then you can start creating an index of things, of these concepts, for instance, so that when you are in the creation tool, you type the name of your class, and then actually it looks in the index to see if that class exists somewhere else. So that you can actually look in the somewhere else and see, that's exactly what I meant. So I'm not going to create that class. I'm just going directly to import this, right? So these are tools for ontologists, not for the communities. But the communities will benefit from that. And the newcomers, that's why we have this group, the newcomers would benefit also for this because there are tons of things they don't know that they can directly apply and are integrated with the tools. So to develop LUMIS, I'm going to go quickly now. Basically, we had an approach where the idea is to look at what are the methodologies that exist for building ontologies. So in OntoCommons, we've been working with our colleague from the University of Madrid, Maria Poveda and Daniel Garrijo, and they came up with a methodology that's called the LOT methodology that is aggregating existing former methodologies like NEON and many others, and aggregated them into one pipeline and workflow, basically. And the idea is that you need to have a process where when you start creating your ontology, you need to scope your ontology. Otherwise, you start modeling the world. You don't want to model the universe. So you have to explain exactly what you intend, how you intend to use this ontology. And then you start doing what we call competency questions. What are the questions I want to be answered by my ontology? And this is going to be a sort of guideline that we'll have throughout the 3 next sessions, because this is necessary. Same goes for a knowledge graph. You cannot go and build a huge knowledge graph without knowing the kind of questions you would like to get answered from by that knowledge graph. And then we also operationalize this. We slice the work into different subtasks, one collecting the user story, one collecting the tools that exist and doing a technical analysis of the tools. Are they cloud ready? Do they have an API? What is the language that was used? Is it Java, Python? Is it web-based and so on, so that we can understand the constraints, technical constraints we will be facing. And then there was also something that Julien is going to present, which is starting to make it real by building a mock-up. So start taking this user story, think about the functions that are associated with this user story, and put it into a drawing that actually visualize the interface and somehow the workflow that you're going to use and the information you'd like to see in a dashboard and a workspace. So this is the LOT methodology. Basically, there are different steps. You can go to the website, lot.linkdata.es, and you will have all the descriptions. And the idea is that this LOT methodology is going to be the backbone of LUMIS, which means that we'll connect all the tools that actually satisfies or contribute to each of these steps. And believe me, there's not 4, there's much more. Okay? So this is the idea that we have our backlog of user stories that we align with LOT. We have done this tool analysis. where basically we start looking at how they've been developed. Some of them are not just one service, they are microservice working together. So how do we connect to them and make sure that we can integrate? And then we have this stories to screen, which is the user story mapping that drives the mockup. And I will leave the floor to Julien to present the mockup. And if you have questions, the idea is that we talk so that you can contribute. And even if you contribute not to the technical part, at least you're aware of that. So when we start talking about LUMIS, now you know what we are doing. And LUMIS is going to be extremely useful in Graphia, because Graphia, we need to build an ontology, right? And so for that, we hoping to use the same methodologies and at some point do the maintenance and the further development using LUMIS.
Okay. So maybe let me give you a bit of context. We prepared this mock-up during the summer, but it's based on the previous work already performed through the last months. It builds on the principle shared by Yann early on, and also it integrates the collective work done through the different work packages and through the discussion we already have around the LUMIS platform. So this is the mockup, and this is the entry print to LUMIS. So our objective is the access is handled through My Access ID, which is the EOSC-wide authentication service developed by Géant. It supports logging with familiar accounts such as Google, OrcID, Daria, or EduTeams. As you can see here, this is something important for us because the objective is to be fully aligned with EOS core services. So by relying on My Access ID, this reinforces our interoperability and trust within the EOS ecosystem. So this logging page is therefore more than a technical detail. It anchors LUMIS as a part of the broader EOS federation of services. So just an example. And here we enter the core of the LUMIS platform, the workspace environment. So each user belongs to one of several workspaces, which are collaborative spaces associated with an institution, for example, a project or a research team. In this case, the workspace shown is linked to Université Grenoble-Alpes. Within a workspace, you will find the list of semantic artifacts. So, as already presented by Yann, we mean all the formalized knowledge resources we need to manage through LUMIS, ontologies, but also some SCORS vocabularies. And the other kind of semantic artifact we want to manage. As you can see, the idea is to organize this artifact in two sections. You have your own interface, I mean the artifact you have created, but also the idea is to have another section, the other artifact available in the workspace, the one shared by your colleagues or the other contributor within the same workspace. So we can see directly some details, some metadata about it. So the type, the current phase in the lot methodology, the last time it was updated, everything related to the current status of this artifact. At the top, you can see several key controls, the workspace switcher, which lets you move from one workspace to another, indicators showing how much storage space is used, the number of members are currently in the workspace, some other shortcuts in the header to create a new semantic artifact or to access the user space with, for example, your account settings and some links to the documentation. So, in short, this screen is the entry point to all the knowledge assets of a given team structured consistently across the LUMIS ecosystem with a strong collaborative approach to share the content of one workspace. So here we move from the workspace view into the detailed view of a single semantic artifact. In this example, the climate change ontology. So what you see here is the artifact metadata section. This is where LUMIS consolidates and displays all the key descriptive information attached to the artifact. So these metadata fields are critical to ensure that the artifact can be properly identified and assessed for fairness, for example. So some key fields about basic identification, semantic description, provenance, governance, technical details also, for example, license, landing page sources, this kind of element. And a key point here, this screen is also the entry point into the lot methodology. On the left-hand side, you see the list of lot phases, requirements, implementation, publication, maintenance, each broken down into lot activities, the subgroups. These actions are directly accessible from the interface, creating a kind of seamless bridge between documentation and execution. This means that from the same place where you edit the identity card of your artifact, you can immediately define your strategy or declare sources, add competency question, we will explain, or for example, apply some control, quality checks, or so on. So for us, it's crucial because this slide introduces for the first time the dual nature of LUMIS. A metadata hub, where artifacts are properly described and contextualized, but also a workflow orchestrator where the lot methodology is directly actionable step by step. The second slide introduced the artifact file view. Here, the idea is to provide a transparent and standardized package structure for every semantic artifact in LUMIS. Of course, we have to discuss about its content, but this is the idea behind. On the left, you see some predefined folder layout, the ontology files, obviously, some validation files based on a specific vocabulary, which is shackle, but these are some details. Some queries to test the ontology or the semantic artifact, some mapping, the documentation, but also the available reports for example, the result of some validation checks or quality checks or fairness checks. We have to discuss it, but this is the main idea. On the right side, we see the ontology folder and the files contained into it, with some metadata. And you can also see that at the top, user can import additional files, download the existing files generated by LUMIS, or refresh the view after updates. We have a dedicated session just after it to discuss about the action we could add or modify. But an important point is this folder structure itself is not really modifiable. The idea is to ensure consistency and interoperability across all semantic artifacts and lot activities. However, the content within this folder is dynamic. User can upload, replace, or remove some files. We want to let some flexibility to the user to be able to add to import your own files and reports or something like this. So this screen is the central exchange interface could be the central interface between user and LUMIS. Then we have another example, the current load status. And this screen is not just a checklist, it is the status engine of LUMIS. It operationalizes the lot methodology by mapping every lot activity to concrete action in the platform. On the left, users see the lot phases and activities. Each activities come from the lot methodology. And on the right, each activity is mapped to an actionable link. For example, as you can see, we have check for existing artifact, ontology conceptualization, open in protégé, etc., unshackle validation. I don't know if I can do it. Sorry. But yeah, this is. Sorry? I'm not sure because it's a diaporama, so I'm not really right. I don't know how I can do it easily, but I guess you have the link. Hola, see if the link is somewhere. It's a fake one.
So everything is in the shared folder of Lumen. If you go to task 2.1, so work package 2, task 2.1, there should be a folder called presentation. And you'll see two folders. One is the OntoPortal presentation. The other one is the IPL workshop. And there you'll have the content. So you can go to the slides. It's available. Everything is open to the partners of the project, right?
Thank you, Yann. It's okay for you, Ola? Yeah? And sorry. So the idea behind is this creates two layers of value. The status tracking, the user instantly see where they are in the life cycle of their artifact. And then I guided a workflow where each lot activity is no longer abstract. You can do some action based on this methodology. So in short, here the lot methodology defines the reference lifecycle, and LUMIS maps it to real actions. And then we can also track all the action performed by an end user in order to provide a complete trace of all recent action performed on the artifact. For example, for traceability, accountability, or status monitoring. So in practice, this log offers both transparency and operational guidance. And then, just to conclude the approach from the overview section, we can also imagine a screen where LUMIS makes the fairness of a semantic artifact visible and actionable. So here, at the top, the multi-tool panel result. So the idea behind is, for example, instead of providing a meaningless aggregated score, we want to display result per external tools in order to help the user to understand better what is the fairness of the semantic artifact he is currently building, editing, and just before to publish it through the different catalog and so on. Another important part I would like to highlight is, as you can see, LUMIS is an orchestrator. We don't want to reinvent the wheel, so we have to manage external tools. For example, if you want to edit a semantic artifact through, you have to do it through, for example, Protégé, which is a dedicated tool to do it. Then you have to, when you click on Edit in Protégé, you will leave LUMIS. That's why we have to deal with this user experience because it's very important. We don't want to develop another tool to edit your semantic artifact. We want to highlight the existing tool and all the ecosystem behind. So that's why here you can switch from LUMIS to Web Protégé, in this example, to edit your ontology. But it's just to illustrate the user journey through LUMIS. So, okay, we will switch from LUMIS and the external tools, and then we can go back to do some other things. And just to conclude this quick introduction of the mockup, we have also some other example. You can create a new semantic artifact. You have also your own user space to share, to set your preferences. And then we are working on some connector if you want to deploy your semantic artifact through your repositories, and if we want to be linked to the other platform for some other purposes. So, yes, now we have to extend this mockup, but also we have to define the strategy behind. I mean, how we want to adapt the look and feel based on the other component in Lumen. So we have to discuss it with the other work packages, but from also a strategic point of view. And then we have to develop the new screens. But before, we have to discuss about some other dimension of the LUMIS project. Thank you, Yann. I'm finished.
Thank you so much, Julien, for presenting this work. and for this amazing work, because that makes the thing real. I just want to mention that the URL you saw on the screen is a fake URL, no worries. It's not there yet, so we need to develop the thing first, and then there will be a nice LUMIS URL.